Hello everybody, thank you very much for coming. Orlando, thank you so much for having me. I find my clicker, it's right here. So yeah, that will be a different talk from what you usually get. Because in this talk, I will convince you that DevOps is actually a nifty plot of ops people against developers. You see the wolf in the sheep's skin? Those are the ops people lurking to bite us in order to make us do their job. Okay, let's start with me getting to know you a little bit more. Who identify themselves as developers? Okay, almost everybody. Any ops people? Okay. Oh, you're going to enjoy it like tremendously. That will be great. Okay, so one. Any DevOps engineers? Okay, yeah. Anyone is familiar with DevOps engineers? Everybody have heard, so aware of DevOps engineers. Great. Okay, remember that almost everybody of you know DevOps engineer, and who thinks they know what DevOps is? All right, okay, so some people think they know what DevOps is. We're going to get to that. Okay, so now about myself. My name is Baruch. I'm the Chief Sticker Officer of JFrog. Also head of developer advocacy. We do have stickers, obviously. So if you didn't get some, please do. T-shirts, I hope everybody got T-shirt. If not, there are some left. The most important part of this slide is obviously my Twitter handle. By now you realize how funny and interesting I am. It'll be a good time to follow me. Now, if you're still not convinced, not to worry, my Twitter handle is conveniently on the bottom of every slide. All right. This is a California disclaimer, a little bit like Proposition 65, but better. This is one of the diagrams of the amazing book called The Culture Map. If you work in a multicultural organization, and you do, you really should read this book. It's amazing. This is a comparison between cultures on expressiveness and confrontational scale. The most emotionally expressive and confrontational people are from Israel and Russia. I'm from both. So if I didn't offend you during this talk, I apologize in advance. But I can guarantee you I'm going to offend a lot of DevOps engineers. All right. So this is the most important slide. If you want to take a picture of the slide, that will be ink. I prepared a special page for you under jeffrog.com/show notes. This is where you go when you want to find the slides. The slides are already there. The video, and we are recording with redundancy. Actually, two cameras. So you will probably get a recording. I'll upload mine tonight, so you'll have it by tomorrow. All the links, including, for example, for the culture map, book and everything else is already there. A place to comment, to rate, and to thank you for being here. A little raffle. You are not that old of people. The chances of winning are good. So go ahead and please participate. We want to give this prize to one of you. If you didn't take a picture of this slide, that's okay as well, because the link for this page is also in the bottom of every slide. So you're good. Right? There it is. Whenever you think like, oh, I need to take a picture of that, just remember the URL. Easy stuff. All right. So I now work in developer relations as the head of DevOps advocacy, but originally I am a Java developer actually. Many years ago, I was a developer and then a consultant and architect and what's not. But yeah, so I'm on your side. But now I'm also kind of lurking with the DevOps people, and I know I see through them because of my developer background. Right, so I was a developer. And so first of all, I will make two claims. First, the entire DevOps thing was invented by DevOps people. That's my first claim. They came with it. And I have proofs. And the first proof goes into the most important books in DevOps ever. This is the Phoenix Project book, and it's a novel about how someone invented DevOps. It's a great book, by the way, and if you are interested in this topic, go ahead and read it. It's also fun to read. It's a novel, so it's not like a heavy hardcore, but the summary, the essence of what's going on, you can get from the cover. Just because on the cover, you see all the main characters in the book. Who read the Phoenix Project? Okay, a lot of people, so you know exactly what I'm talking about, right? So we have here Patty McKee. She's Director of IT Service Support. IT Service Support is Ops IT. This is Bess. He's Director of Distributed Technology Ops. Obviously, Ops. Right? This is Sarah. She's SVP of Retail. This is Sales. And this is Steve, and he's a CEO, acting CIO. And this is Dirk. He is the CFO, of course. Bill Palmer, that's like the main hero. And he's obviously VP of IT Ops. Right? And this is Eric, board member, and this is Brent, lead system administrator, very, very ops. And this is their chief information security officer. Notice something strange? The most important book about DevOps, there are no developers in the story. I mean, there are developers in the story that are completely irrelevant for the plot, and they're like just hanging there and waiting for ops to tell them what to do and how to save the company. Now, if that's not enough, let's take a look at the next book. And that's the DevOps Handbook, and this is how to do DevOps. Also, very important book in DevOps world. Who read the DevOps Handbook? Less people, obviously, because it's a little bit less engaging. Here, you know what? Let's look at the authors. Jim Kim, Jez Hamburg, Patrick Dubois, and John Willis. All wonderful people. I love them all dearly. Great friends. One problem. Patrick Dubois, system architect. That's very ops. Jez Hamburg, Deputy Director of Delivery Architecture. That's delivery, that's ops. John Willis, VP of Services in Chef, what used to be called Ops Code. And obviously we already spoke about the author of the Project Phoenix as the book. Okay? All DevOps was invented by ops people. Right? And if you go to, even just Google what is DevOps, look who are trying to explain you what is DevOps. First explanation, New Relic. What New Relic does? Observability, monitoring. That's completely ops story. Next one, Amazon Web Services. Ops infrastructure in the cloud. Next, CollabNet. Okay, CollabNet is kind of an exception because they do have tools for developers, but then we go again, the Agile Admin. And then Wikipedia, Atlassian, that's a mixed bag, and then again Microsoft Azure, again, ops infrastructure in the cloud, right? All this story, they are leading with, let us tell you what DevOps is, right? So, I guess you'll agree with me by now that actually DevOps is all ops. Now, the story, the question is why? Why do they need that? And I have two reasons for you why the whole DevOps story was invented by ops. The first is, sysadmin is not a very sexy role. People don't want to be associated with, they crawl under the tables and connect their printers to work. Instead now, they want something new and shiny, DevOps. So how do I switch my job from sysadmin to DevOps? That's Quora. And basically the answer is from online trainer for the last 7 years, someone very respectable. You see they have DevOps as their image and everything, like very people who understand about DevOps. Okay, being Linux administration is a great start. It's basically all you need, plus some more tools, like cloud computing, DevOps fundamentals, software development lifecycle, continuous integration, deployment and delivery, and DevOps tools like Gits, like many Gits, I don't know, Chef, Maven, okay, Jenkins, Puppet, Docker, etc. No Jeffrey, by the way, wrong answer. But okay. So, this is what it is. You take a system administrator, you teach them Gits, and they're DevOps engineers. Right? And why would they do that? Because money. Look at that. System administrator salaries in the United States, under 65 grand. DevOps engineer salaries. You take a system administrator, you teach them Gits, and they earn like 30% more. How wonderful, 50% more, 50% more. How wonderful is that? I mean, that's a good plan. And it's not that it doesn't work. It worked very well. 15,000 open positions in the United States for system administrator who know Gits. It's insane. It works, it's great. Another reason is, as I mentioned, making us, the developers, do more work. This is the infinity loop. That's the official explanation what DevOps is. You go through all the stages of development and all the stages of operations together. They're intertwined, they're interconnected. Anyone? Does this diagram look familiar to anyone? What it reminds you of? Another diagram, huh?
Infinity.
Well, yeah, infinity, of course, that was the idea, but it reminds of another diagram. Anyone? With steps as well? Agile. Look, it's exactly the same. But now, they said, okay, you are the developers, have your own diagram, now do twice the job. Do this all over here. They want us to do their job. Here's another proof. State of DevOps report. That's by far the most important research done in the DevOps world every year. And I'll start with previous year on purpose, and then we'll get to the new one, because there is a very, very important point here to prove the same idea. They want us to do their job. So, in DevOps report, there are 4 different, 2018, there are 4 different metrics of a successful implementation of DevOps. Successful implementation of DevOps. Deployment frequency, how frequently we deploy to production. Lead time for changes, and that's how fast the code commit goes successfully to production. Time to restore service, if everything is broken, how long it takes to get back up. And change failure rate. When we deploy applications to production, what percentage of them is broken during the deployment? Right? Deploy, going from code further, unplanned outage, degraded service. What is this crap? What do we have to do with any of that? That's, again, completely ops terminology. That's ops speak. That's how wonderful or miserable they are deploying our code to production. It really has nothing to do with us. And now look, the big story about DevOps, according to DevOps report, and obviously that's true, is getting more new work. Right? This new work is extremely important because this new work is where the money is. This is we work on new features, and obviously everything else is we are not working on new features. Now, that's interesting because we can look now at the sort of work they are employing and decide if that's the right work. So, types of work in the Phoenix project and Dora report. Planned work is business projects or new features, and that makes sense. internal projects, server migrations, software updates, and so on. Changes driven by feedback and complete work. Unplanned work, support escalations and emergency outages. I mean, this is fine, but again, what it has to do with us? Deployment, outages, working on tickets, like IT tickets, that's not what we do. What we do is very simple. Either we write new features, or we fix bugs, or we refactor our code. This is all. New code and not new code for us is new features or refactoring and bug fixes. This is all we do. Unplanned outages, escalating from IT, this is not development story, this is an ops story. So, DevOps report are trying to teach us that what's important for DevOps is what's important for ops. Nice try. And I think with that, you will agree with me that DevOps is an ops plot to get us developers do their work. Now let's see what happens. So as I mentioned, I was a developer, but it was a long time ago. It was like, it's been a while. And back then, and I still feel now, and you will correct me if I'm wrong, our job, what good looks like for developers, what's important for developers, it's described very well in all kinds of manifestos. Software craftsmanship manifesto is a good example. Look, not only working software, but also well-crafted software. We care about the quality of our code, yes. Not only responding to change, but also steadily adding value, right? That's the refactoring and everything else. Not only the individuals, but the community of professionals. We developers should talk to each other, yes. Not only customer collaboration, but productive partnerships with the customer. I think everybody can get behind those. Every developer can get behind those. This is what good looks like for us, the developers. And this is, again, looks very, very familiar. And let's look at that a little bit better. This is a slide from a great talk by a friend of mine, Anton Keks, who is a part of an outsourcing company that is driven by this craftsmanship manifesto. That's the thing they care the most. This is how they distinguish themselves among others. It works very well for them, and this is how he defines what's important. They call it code board, by the way, and if you ever need good developers, the best developers, I highly recommend. This is how he describes what good looks like for them. Okay, full stack developer, when full stack is a matter of doing everything that is needed, not like front and the back. So let's see. Collection of technologies needed to complete a project. Polyglot developer, you know everything. You learn the essence and can apply to any language technology. You still learn more in the part deeply as you gain experience. Structure and design, security, logging, auto testing, simplicity. I guess we all agree to that. And then the ops part. Also deployment. Why you care about deployment? Because you don't want angry admin to wake you up in the middle of the night. Makes perfect sense. We do our work. We do it good because we don't want the other folks to wake us up. But our job is done here. Everything that goes later should go smoothly. We prefer it to go smoothly because we don't want to be waked up. But this is not our job. Okay. So here is my summary of software craftsmanship definition of done. We understand what needs to be done. We understand the requirements. Our code is readable, simple, understandable. Our code is easy to deploy. That's important. Non-functional requirements are met. We didn't incur any technical debt and even reduced some. Our test pass. QA took a look and they're happy. Team lead took a look and they're happy. Product owner took a look and they're happy. and client took a look, and they are happy. Anything to add to that? Again, I hope we all agree that this is something we all can get behind. Great, sounds good. But here is the twist. You heard a lot, especially in the past, about this, for me, completely imaginary rivalry between the developer and the tester. Why I think this rivalry does not exist and it's completely imaginary? Because we, as good developers, we care about quality. Right? You saw that. QA took a look and they're happy. We want the software to be working. We want actually to fulfill its purpose. We care deeply about quality. So there is no rivalry with the tester because tester helps us to achieve this quality. We're best friends with them. They help in us be better craftsmen. So this is false. Now, I completely forgot what I wanted to ask you here. So, yeah, I wanted to ask you if you are agreeing to the previous statement. Okay. Yes, that's a very Soviet thing. Okay, so yeah. I wanted to ask you, who thinks that quality is important? Everybody does. Who thinks that QA is kind of a rivalry? No one does? Perfect, right? Because quality is important. We want to get better on what we are doing. Now, again, back to my history, I just keep reminding you how while it was when I did the last. 2010, there were different requirements from quality in 2010. Let's go back in time. This is the side of the website of Chase, the bank. I mean, I selected because it existed. There are a lot of banks that didn't have a website in 2010, but Chase did, and it also had, like, you know, your login. You could enter there and probably see your statement or something. Not more than that, right? It's not that you could actually do something, but you probably could see your balance and what's not. And having this as the website of your bank, obviously no iPhone or smartphone apps, nothing. You sometimes saw this message of maintenance, it will be down overnight, and we didn't care. That was fine. That was an acceptable quality for a bank website. Okay, so it was down for a couple of hours, not a big deal. Just because, anyway, we didn't have anything to do with it, anyway. It wasn't very useful. But today, obviously, the requirements are completely different. Right? I know a lot of people, and myself included, that actually switched banks because the quality of their mobile apps. Anyone else? Here we go. Even here, some people did that because now our requirements for the quality of the software is completely different. And one of the problems that we see now with quality is not that those testers or QA people forgot how to do their job. The problem is with data. Code quality is not enough because now with this amount of big data, we don't even have a way to guarantee this quality because there is some. By the way, what ZB stands for? Zettabytes. And for you to understand how big zettabyte is, what now is kind of the unit of big data? What, like when you hear that and you say, well, they have big data? Petabytes, right. So after petabytes, which is now a lot, that's like Google's and Facebook's and Twitter's are petabytes, there is one more, which is called exabyte. Now exabyte is 1,000 times more than what we consider now big data. But this is the next one. This is zettabyte. It's like a lot of data, like really a lot. Well, this report is prepared by Seagate. they sell hard drives, so they might be some bias there. But even, divided by 10, it's still something we cannot even imagine. And with this amount of data, some concepts just go out of the window. For example, the concept of staging server. There is no such thing as staging server anymore because it doesn't make any economical sense to even try and mimic your production environment with this amount of data. Just because it's so expensive, it doesn't make sense. Instead, what we do, we test in production. Well, we panic, but then we test in production. There are tons of new concepts that allow us to test in production. My favorite here is when you do a controlled rollout, is the, blast radius, reusing the blast radius. The idea is that you throw your software at the world and then you see who dies. And you try to make it like less. I love it. That's great. But yeah, the idea is we cannot do staging anymore. Instead, we have our software tested to the best of our ability, and we throw it in production and see what happens. And hopefully not a lot of people suffer. But this means that we, as software developers, suddenly care about a completely new realm. Now, we suddenly care about production. We just agreed we care about quality. And that means that until we see this blast radius, and we say, well, this deployment went okay, it's only 2% that suffered, the blast radius was fine, we cannot say our quality is good. Now suddenly, we care about the quality in production. And that means we need to be there when our deployment lands and does the blast. And that means that we have to be there on call with the ops people, with the QA people, because if we care about quality, we cannot ignore what's going on in production, because this is where, in the end of the day, as of today, and especially tomorrow, our quality will be judged by. So this is our definition of done from the last slide, and now suddenly we have a new one. SRE took a look and they're ahead. The only time SRE takes a look is in production. So we need to be there to know if they're happy or not. What is SRE? SRE stands for Site or Service Reliability Engineer. And this is a Google term that probably was invented to make us Google it or whatever. But it's a term. This is what happens when you treat operations as it was a software problem. And this is obviously a very ops term, and this is a new title for people who take care of production. But again, I can show you the salary comparisons. Trust me, it looks good. When you call yourself an SRE, everything works for you in life, except of being on call. But everything else does. So now we not only show it to the QA people because we are friends with them, and this is how we guarantee our quality. We show it to operations people and get okay with them because this is how we guarantee our quality. And what does it mean when this site reliability engineer or service reliability engineer will be happy? What is their requirements? Their requirements are they understand how our code is going to be deployed. Not only we think our code is easy to deploy, they think that our code is easy to deploy. The build is reliable, repeatable, and fast. And fast is very important because, you remember, we test in production. Now we are in the middle of deployment, the blast radius looks not so good, we need to fix something, we need to run a build. Our build cannot run for 8 hours now. It should be fast and also repeatable and reliable. Our code is stateless because now they want to throw it in Kubernetes and they want to scale it. Our code needs to be scalable, and that means most of the time it should be stateless. Our code starts fast and dies fast. Again, going back to all this notion of kettle notepads, they're going to kill a lot of servers and fire up a lot of new servers. All that should happen very, very fast. Our code is observable. In the end of the day, now we are all on call. There is an incident, we need to be able to see what's going on. Our code supports feature flags. There is a blast radius, but instead of trying to come with a patch immediately, we can just turn off the misbehavior feature by using an API. Our code backwards and forwards compatible. Backwards compatible obviously because there are old clients there that need to be able to talk to our code. But also now we release something, part of our clients got updated, but then we need to roll back and they need to be forward compatible as well. Our code emits event streams that goes back to observability and knowing what's going on in runtime. And this also looks very familiar. Anyone knows what this looks like? There is a website called the 12-factor app. This is, for many years now, the grocery list for cloud-native application that runs in the cloud. And it's exactly the same list. Code base, track and version control dependency, that's obviously build, release, and run, that's about the build. Execute stateless processes, scale out, disposability means die fast, logs, that's all this stuff. So this is a lot of what we spoke about. There are some pieces missing in the 12-factor app, and since then there is a new thing called beyond the 12-factor app, and there is like 15-factor and 18-factor and whatever. But at the end of the day, the list that I show you, this is pretty much what will guarantee that SRE will love your code, and that means that your professional requirements to quality are fulfilled. Right? One more item to add here is our code is lean. And by lean, I mean it's as efficient from economy point of view as it can be. For us developers, it doesn't really matter. Writing code which is wasteful or writing code which is lean is fine either way, as long as it fulfills the other requirements of the craftsmanship. But if we are to satisfy our SRE, we suddenly need to think about economical implications of our code. That's a very strange concept for us, the engineers, because we never deal with it. But the impacts are huge. That's obviously the AWS build that our organization, the SRE, tries to reduce. And this is their job to reduce it. This is whom the business comes demanding why your bill this month is bigger than the last. But in the end of the day, a lot of it is in our hands. Look at this example. This is Kafka Summit. Achieving, that's a talk by Uday Sagar from Signal Effects, achieving 50% reduction in network costs from Kafka. Software engineers managed to reduce their cloud bill by 50% by writing better code. And this is a requirement that your SRE will come to you, but Business actually now comes to you with this requirement. So not only now you need to satisfy your SRE, through your SRE, you actually satisfy the business requirements for cost reductions. And trust me, this is in our software engineers' best interest. Because when we need to have costs, what we can do? We can lay off people. We can cut on operational costs. Or we can switch to serverless and move to the cloud and cut cost of code through code. So next, when you are a software engineer and you are panicking about layoffs or paying for coffee, what you need to do is write better code. And by better, I mean everything that we spoke of, but also lean to save your company money, because this is exactly how you're going to keep your job. Right? And if now we take interest in what our business wants, let's talk about what our business wants. And our business wants more happy customers. And what the customers want, they want features. When the customers want features? Yesterday, obviously. Right? So our ability to deploy faster helps business to achieve their goals and help us to keep our job. This is, again, the Dora report, and you can see here how important it is. The elite performance by those parameters that we spoke about, deploy more, deploy faster, recover faster from an incident, and suffer less failure rates. So the elite performance, this is the organizations when the SREs went to the developers, explained them why they need DevOps, and the engineers actually start writing better code that their SRE likes, can provide more value to their customers faster with less failures. We also need to improve our security. One way to do it is hire a Chief Information Security Officer, so we will have someone that we will fire when the next breach happens. Or we can start thinking about continuous security. Whoever ever got their driving license probably know this picture. This is how stopping distance is calculated. It has two different parts, completely unrelated to each other in terms of their physics. There is the thinking distance and the braking distance. Thinking is, we get light from the obstacle into our retina, it sends electric signals to our brain, and then we send another electric signals to our leg, and then it hits the brakes. That's the thinking. And the braking is physics and chemistry. The braking pads are putting pressure, and then the rubber and the surface, and obviously that's a completely different story. We also fight those two and try to reduce them, because that's our interest, obviously, with completely different approaches. Braking distance, we come with better alloys for the braking pads, and better rubber for our tires, and better pavement for our roads. How will we battle the thinking distance and short that? We replace small, very slow humans with machines. They are much faster. Right? But the security is absolutely the same. Fighting every security vulnerability have completely different parts that needs to be tackled from completely different angles. Identify that we actually know that there is a problem. This is observability and honeypots and a lot of other tricks. Fixing is usually 90% of the time just upgrading our dependencies, because 90% of the time, the vulnerability is not our code, it's actually the dependency that is vulnerable. And all we need to do is update them. And it goes starting from operating system, which is the dependency, all the way to this struts component that made Equifax possible. And then we're back into our story. The DevOps, the SRE, the developers, how do we deploy faster? So again, in the organizations in which the SRE likes what the developer does, those are the elite performance from DORA report, they are able to shorten this part to almost 0. And that obviously shortens the entire story. And sometimes we have problems that can only be solved after the fact. So you remember Spectre and Meltdown from last year? Meltdown was the big news because it was like 10 lines of JavaScript code that steal passwords from the areas of the memory. But actually what's much more frightening is Spectre, because Spectre is impossible to defeat. And Spectre is impossible to defeat because the way it works is that the attacker speculates on how the speculative execution of CPU will happen based on the code that you write. How do they know how the code that you write looks like? Because frankly, all the code in the world looks exactly the same. We use best practices, we use design patterns, all the applications look exactly the same. And if I can analyze those best practices and then successfully guess how the speculative execution of the CPU will work, I can guess how the speculative execution of the CPU will work for the majority of the software in the world. So basically, the better quality code we write, the more we are exposed to Spectre class attacks. And this is fine. We're not going to start writing shitty code now just to confuse Spectre. Instead, we will be on the lookout and we will be able to identify, fix, and deploy as soon as possible when the problem occurs. Right? Again, this is all helps us providing more features and battling security threats. Right? So, by now, I hope you understand that DevOps, except of being the evil plot of ops people, is actually an evolutionary pressure. It had to happen because the companies that implement DevOps actually more successful. They're more successful than their competitors because they deliver features faster, and they're also more in a better posture to fight security threats, which are obviously critical to all of us. So DevOps is just a mean to an end. It's not a goal by itself. And DevOps help us to achieve quality, lean software, saving money, providing new features, and security. So yeah, this is where we are. We might think, or we might know by now, that DevOps is an ops plot, but it's actually an evolutionary need that makes a lot of sense, whether we like it or not like it, and regardless of who invented it and why. By now, it is proven to make companies better, and this is why we don't have choice. So, back to this infinity loop, now this is where we live. And the good news are that we are not alone there, but the ops folks are actually pushing us there all the time for a very good reason, and wait for us to actually do that more successfully, not because they're evil and lazy, but because this is what business demands from them and from us. And obviously by now you understand that the term DevOps engineer doesn't make any sense, because we just spoke about it. DevOps is how we work as a company, how we work as the team, how we collaborate. DevOps engineer makes as much more sense as a collaboration engineer. Obviously, this is not a real term, and DevOps engineer is not a real term as well. Now, here's when you say, yeah, but there are still 15,000 open positions for DevOps engineer. And that's just a terminology mix-up. The 15,000 open positions are, and you know it by now, for the service reliability engineers. Those who will lay out the pipelines and the infrastructure for all of us as the organization to deploy to production better. So, I mean, I'm on a crusade to eradicate the term DevOps engineer. More or less, every HR in the world is against me, so I don't have a lot of chances. But now, at least you know to hear site reliability or service reliability engineer every time you hear the term DevOps engineer. But that's like when people really understand what they're doing. But now you are. And just finish with the good news a little bit. You might by now be very terrified that I'm forcing you to do DevOps regardless of what you like it or not. The good news are you're going to like it. You're going to like it because things are changing. In the ops community realizes, as we just did, that we all need together. And when you look at the new state of DevOps report, suddenly, look at that, 30% more than any other group of the respondents to DevOps report are development or engineering, more than actually DevOps or SRE. Suddenly this report is turning towards us, and now it's a friend instead of a foe. And you look at the metrics, and here we start to see metrics which are related to software development as well. And now DevOps people realize that lead time, the time from the idea of the feature to production includes this part of actually writing the code. It doesn't appear and lead time is on, so okay, we have the code, let's get it to production. We actually need to write the code, and now it is a part, lead time is a part of software development method. So this education goes both ways. And frankly, SRE itself as a profession is actually software engineering, writing code. Because just to remind you, SRE is what you get when you treat operations if it was a software problem. So we expect those service reliability engineers to understand the concept of software delivery. And concept of software delivery is right. And I think I forgot to put it in a slide, but this is also very, very important change. The new book, the sequel, if you wish, for the Phoenix project called the Unicorn Project. Anyone read the Unicorn Project? Okay, a couple of people, and you read the Phoenix project as well, right? So you saw the difference. Just to remind you, the Phoenix project, it's about an ops manager that invents DevOps. The Unicorn project is about a software engineer that managed to reform their organization to DevOps. The main character of the Unicorn project is a software engineer. So this change, and it's from the same people, it's still drinking. This change exists on both sides. We understand that we have to live with DevOps. The ops people understand that DevOps cannot happen without software engineers, right? And the people who implement DevOps, they are a little bit like that. They are both in ops and both in dev, and obviously we cannot be very deep in each and every one of them, but we definitely need to understand the big picture. As we expect the ops people to understand that there is code to be written. They expect us to understand that there is a code to be deployed. And you remember all the requirements that we came. So, good news, everybody. DevOps is an ops idea that I still stand behind my proof that that's true. But business liked it, and it's quality, it's lean, it's competitive advantage, it's security. Of course business likes it. And it's not as bad as it sounds, because you remember, now everything is a software problem. Software problems, this is what we like. We're very good in that. And all we need is to follow the principles of DevOps, the best practices, and this is, we know how to do, because this is what we are doing. So, good news, everybody. DevOps is okay. With that, I have to remind you about my Twitter, because now you really don't have any reason. This is it. When you praise this amazing talk on Twitter, don't forget the Untitled Chapter hashtag and the DevOps hashtag. Let's get those people excited. And obviously, everything is at jeffrey.com/show notes, the slides, the video by tomorrow, all the links, and don't forget to participate in the raffle. The prize there is really for you. With that, thank you very much. Questions? Questions? We can just go home. That's fine as well. Yes.
Thanks for your presentation. What's your opinion about responsibility of developers? I mean, based on the presentation, probably I know the answer to that, but one of the motivations that people say why the DevOps is still there is people will need responsibility when they run some technology that they chose, and this is how they know that they have to be very careful when they pick something.
Yes.
So the question is, do you see it as a motivating factor for other companies to switch to DevOps, so that was primarily about security, like you said, automation, business benefits? Do you see it as a real benefit for dev teams to?
Yeah. So the question was, how DevOps now affects our decisions? Do the fact that we now have more responsibilities should affect our selection of technologies, of frameworks, of dependencies, code languages, code styles, and whatnot? And obviously the answer is yes, because now when we accept the responsibility for much more than just our code is clean and nice and we like it, now we accept responsibilities that it needs to be lean in production, and it needs to be secure, and it needs to be scalable. Now our decisions have to be driven by that. So for your next programming language, you might suddenly select Go. Why? Because Go is very good for containerization. Who cared about that? If they want to pack it in a container, let them go ahead. Now suddenly, it's our interest because we know that we can go serverless and reduce cost. Go has a very good concurrency. Who cared about that? Let them throw more hardware on it to achieve the same concurrency levels. Now we suddenly care about that because this is the money that we are responsible for. So now we need to select a language with better concurrency. And all those requirements we didn't care about them, and now we do. The same with our libraries and dependencies. Do we want to look at Spring Boot instead of Java EE? Do we want to look at Macronaut instead of Spring Boot? Because suddenly all of those have implications that we didn't think about. Another one is security. Now suddenly we not only select the best programming paradigm of our framework because we like it, we'll also look at the record of their security vulnerabilities, and not if they had any, because this is out of their control, but how fast they can provide us with a fix, because that's the second part of this three-stage diagram of bottoming the security fix. We are in charge of the deployment, but if the fix is not there, even if we can deploy immediately, it won't help. So that's suddenly another aspect that we need to look at. So yes, the answer is suddenly our decision making is much harder, and it's also our responsibility to make sure that all that happens. Because the ops people won't be able to help us choosing between PHP and Go or between Java EE and Micronaut. This is completely on us, and our decisions have to take into account all those points that we spoke about that SRE requires. Does that make sense? Yes?
One thing that seems to be missed when we have DevOps discussions is we're the developers, they're the ops. There's a spectrum of all the things that should be laid out. But what we avoid, and I don't mean we being you, but I mean we in our projects avoid is the build, the test automation, static code analysis, the profiling. Those are the pieces where I find every project I work on, no one cares about.
Yeah.
So that, I think, when you say DevOps, they should be picking up at some point in time. I'm a developer. I want to write code to solve a business problem, and I want someone else to pull it out of Git, build it, code quality test it, run my unit tests.
Yeah. So I guess I didn't do my job very well. If that's still your opinion, because the whole idea of DevOps is that suddenly you cannot just claim, you know what, I'm a developer, I write code, someone has to take the care of the build. Not because you need to be responsible and take more responsibility, no. Because your professional integrity depends on the quality of your code. And until this code is built, tested, run in production, and not a lot of people died, you cannot be pleased with yourself professionally, in terms of professional integrity, that your code is a good quality. So no one else is going to do that for you. It's like you're saying, you know what? I'm just writing code. If it doesn't compile, it's not my problem. Bring in the compilation engineers, let them compile my code. You don't do that. You expect everybody, we except for ourselves, that our code is obviously compiling and running and of a good quality. Unfortunately, today, we cannot satisfy ourselves about our quality without the pipelines. And that means it's our responsibility. Do we know everything about it? Do we know everything about all those build tools, dependency managers, the CI servers, deployment tools? No, we don't. But that's okay. For that, we have other people that can help us. But the responsibility is ours. We cannot avoid it by saying, well, bring the build engineers now. They will build the code for us. Not anymore. Not since the 70s. This is our responsibility now. I mean, it's a little bit like, oh, they do their work for us, but it's also a software problem. It's something that we care about, we know how to deal with, and it's interesting. So, yeah, there is no reason why not to absorb this responsibility, especially if all the sides of the conversation in the organization are there to help each other instead of throwing the work from silo to silo over the fence. Yes?
What are your thoughts on embedded DevOps resources in a team versus an independent DevOps team?
Yeah, so this is, what are my thoughts about embedding DevOps resources in the team as opposite to independent DevOps teams? Now, independent DevOps teams who build out of DevOps engineers don't make any sense. Because if you have a team which is sitting there and waiting for something to happen in order to go and do their work, this is not DevOps. And you can call them DevOps engineers instead of system administrators, and you can call this team a DevOps team instead of calling it an Ops team. It doesn't matter. As long as you don't collaborate in the same empowered team on all the aspects of software delivery, starting from writing code, testing code, building code, and all the pipeline to production, this is not DevOps. The only way those teams can be successful if we sit together because we all know different things. And as the gentleman mentioned, I don't know all this stuff. It's like weird to me. But in your team, there is someone who knows. And then you work together in one team to deliver your software to the world. Chances are, if you have an external team of system administrators that you call the DevOps team, it will still be the same. They will wait there for work magically to appear, and you will feel like, well, my job is done, I will give them whatever code I have, and let them deal with it by themselves. So, DevOps teams make even less sense than DevOps engineers. One of the reasons I oppose so much to the term DevOps engineers, because you take DevOps engineers and you put them in DevOps teams. And this is what disables all the purpose of DevOps entirely.
So, in favor of DevOps teams, you have DevOps, two kinds of DevOps. Working with the teams and enabling the teams to deliver, but then you need someone to set up processes, tools, to develop new tools, to develop new processes.
Absolutely.
Like enterprise sort of things.
So there is something else that the better term for that will be infrastructure teams. Infrastructure teams work on infrastructure for enabling economy of scales for teams across the organization. They are the ones who will actually take care of big projects of laying out infrastructure for those pipelines. And obviously, there is a place for that. The reason I don't emphasize that is because they trend to become the DevOps teams in the bad connotation of the word, right? Because at the end of the day, well, we have the DevOps team here. Why do I need a DevOps engineer in another team? Let's consolidate everything in the DevOps team, and then we have the problem that I mentioned. Well, it can be done, and it is done in a lot of organizations, especially we in JFrog work with those teams, right? So enterprise enrollments of JFrog software is usually done by those teams, and that's fine. But this is true for certain class of organizations, the ones who need this unified infrastructure in order to save money. And as I mentioned, since it really trends to demolish the whole idea of DevOps, if not done correctly, it's kind of, I don't feel the urge to advocate for this type. Although, again, we work with them, some of them know what they're doing in terms of keeping the infrastructure team different from the DevOps teams, which are the rest of the teams, but it's hard and it's tricky. All right, so I guess we have more beer, more pizza, more networking to do. Thank you.
And a raffle.